For nearly a year, a spacecraft 5.9 billion miles from where you're sitting stopped listening to us. No commands went out, no data came back. It simply went dark on purpose, drifting through one of the coldest, most distant regions of the solar system, waiting for a wake-up call it had been given a year in advance. On June 23rd, 2026, that wake-up call finally happened. And what came back confirmed something remarkable. The spacecraft had survived its longest silence ever, completely alone, farther from home than almost anything humanity has ever built. This is the story of New Horizons, and why the fact that it just woke up matters a lot more than a routine status update. I'm Your Name, and this is your channel. If deep space stories like this are why you're here, subscribe now, because we're going further into what NASA isn't putting in the headlines. Let's start with where New Horizons actually is right now. It is approximately 5.9 billion miles, 9.5 billion kilometers from Earth. That's 64 times the distance between the Earth and the Sun. To put that in perspective, light itself, the fastest thing in the universe, takes almost 9 hours just to travel that distance one way. When NASA sent a signal to confirm the spacecraft had woken up, it took 8 hours and 52 minutes to arrive back at the Deep Space Network station in Madrid. Almost 9 hours, one direction, just to say, I'm awake. New Horizons has been out here a long time. It launched on January 19th, 2006, at the fastest speed any human-made object has ever left Earth. It swung past Jupiter in 2007 for a gravity boost. And in July of 2015, it did something no spacecraft had ever done before. It flew past Pluto, giving humanity its first close-up look at a world we'd only ever seen as a blurry dot. 4 years later, in January 2019, it went even farther, becoming the first spacecraft in history to fly past a Kuiper belt object, a small ancient snowman-shaped body called Arrokoth, over a billion miles beyond Pluto. And it kept going. In October 2024, New Horizons crossed 60 astronomical units from the Sun, twice the distance Pluto sits at. It is now deep in the Kuiper belt, a vast ring of icy debris left over from the solar system's formation, heading toward a boundary that very few instruments in human history have ever directly sampled. But here's the part that doesn't get talked about enough. To survive out here for 2 decades and counting, New Horizons doesn't run continuously. Every so often, when there's nothing urgent to do but cruise through. Empty space, the mission team puts it into hibernation. Most systems power down. No commands go out, no data gets pulled back. But the spacecraft doesn't go completely silent. Its scientific instruments keep quietly working in the background, gathering measurements of the environment around it, storing everything on board, waiting. This last hibernation period was the longest one yet. 321 days, beginning on August 7th, 2025, based on commands the mission team had uploaded a full year earlier in July 2025. Think about what that actually requires. You write instructions for a spacecraft to fall asleep and wake itself back up nearly a year. Later, entirely on its own, with no way to intervene if something goes wrong in between, you send it, and then you wait. For 11 months. During that entire stretch, the only thing coming back to Earth was a simple, weekly status beacon, a small signal just confirming the spacecraft was still alive. According to Alice Bowman, the mission operations manager at the Johns Hopkins Applied Physics Laboratory, every single one of those weekly reports came back green. All was well, week after week, for nearly a year, on a machine with nobody watching it up close, running on its own in one of the coldest, darkest regions our solar system has to offer. Then, on June 23, 2026, the stored commands did exactly what they were built to do. New Horizons woke itself up. And the mission team on Earth spent the following days confirming what they already suspected. The spacecraft had come through in good health. Now here's why this actually matters, beyond the relief of a successful wake-up. While New Horizons was hibernating, it wasn't idle. 3 of its scientific instruments kept running the entire time. The solar wind. Around Pluto Instrument and the Pluto Energetic Particle, spectrometer science investigation were both continuously monitoring the outer Heliosphere, the vast bubble of solar wind that surrounds our entire solar system, the same boundary Voyager 1 and 2 crossed years ago on their way into interstellar space, and the Venetia Burney Student Dust Counter, an instrument literally designed and built by students, was tracking the dust environment in this distant region the entire time, unattended, for 321 straight days. That data hasn't just been sitting there for nothing. New Horizons is heading towards something scientists have been waiting decades to study directly: the termination shock, the point where the solar wind, streaming out from the sun at supersonic speed, suddenly slows down as it crashes into the pressure of interstellar space. Voyager 1 and Voyager 2 crossed this boundary years ago, but their instruments were built in the 1970s, far less sensitive than what New Horizons carries. According to Pontus Brandt, the mission's project scientist, when New Horizons eventually gets its own close encounter with this boundary, the data will be, in his words, a genuine treasure trove for space physicists trying to understand exactly how this vast, complicated barrier actually works. That matters here on Earth for the same reason Voyager's data matters. This boundary, the Heliosphere, is what shields our entire solar system, including us, from the harshest radiation drifting through interstellar space. Every additional instrument we get out there measuring how that shield actually behaves is another piece of a puzzle that affects the long-term safety of everything living inside it, us included. There's also something almost poetic about the timing here. Right now, humanity has two generations of deep space explorers working this exact same problem from different angles. Voyager 1 and 2, now nearly 50 years old, running on a few watts of power, still transmitting from actual interstellar space beyond the boundary already. And New Horizons, only 2 decades old by comparison, but carrying dramatically more advanced instruments, still approaching that same boundary from just inside it. 2 different machines, launched decades apart, both still working, both still teaching us things no ground-based telescope ever could. Since waking up, the mission team has begun downlinking the spacecraft's health and safety data first, followed by the actual science data collected during hibernation. In about 3 weeks from the wake-up, New Horizons' ultraviolet spectrograph, called ALICE, will begin looking specifically at hydrogen gas distribution in the outer heliosphere, more direct measurements of exactly the region we're talking about. At the same time, engineers are running spacecraft and instrument checkouts and completing upgrades to the ground software that controls the mission, because the challenges of running a spacecraft this far from home keep growing. New Horizons is now operating on updated autonomy logic, specifically designed for conditions farther from the sun, accounting for its slowly declining power supply and the steadily increasing radio delay that comes with every mile it travels outward.